Okay, for the last one, we are going to do the potential and kinetic energy, which is going to be the most difficult one. So let's get started. Here we go. And very quickly, I'll go through the notes with you so you know what they are. Potential energy is basically stored energy, and that is a definition that you need to know. You also need to make sure that you have memorized the equation for the potential energy, and specifically this is the gravitational potential. So we should probably enter that, gravitational. And that is anything that has been lifted. Hang on, let me turn the dishwasher off. I think it's too loud. Just wait to turn that on. All right. That said, m is your mass, g is the acceleration due to gravity, and h is how high off it is from the ground, or the 0 point. So it doesn't have to be off the ground. If it's in my classroom, 5 floors off of the ground, the 0 point, or the height, can be measured from the floor as well. Okay? That said, this here says it's the acceleration due to gravity. Later on, it just says gravity, which is incorrect, because that would be that really ugly calculation that we just got done studying. That said, kinetic energy is the other thing that we want to take a look here. That is the energy of motion. All of this, potential and kinetic, these are mechanical energies. And those are any type of energy that causes motion. So all of these forces that we've been talking about, they're caused because we have mechanical energies. And you have work being done to transfer energy into an object that's being given potential by being lifted above the ground, or the 0 point. Or if it's being dropped from a height, it will start to speed up. And as it speeds up, that transformation work is being done in order to give the object kinetic energy. Kinetic energy is the energy of motion. So it's very important that you know the difference between these two things. The formula for kinetic energy is 1/2 mv squared. And we're going to talk about this a little bit right now. M is the mass, v is still velocity. If you notice, all these representations are always the same regardless of what type of equation they're in. They are standards in physics. And we want to make sure that you square it. So we're going to talk about the squaring a little bit more as we go through some examples. If you are calculating an energy, you are always calculating it in joules, okay? Which is the same thing as a meter, a Newton times a meter, okay? That said, here are your examples. You have a 50 kilogram boy. Kilograms means mass. And his 100 kilogram father. So we have two masses here. I'm going to call this MB for the mass of the boy, and MF for the mass of the father. Stop laughing. Both ran at the same speed. Speed is the same thing as velocity, 5 meters per second. Who had more kinetic energy? If you're going to calculate kinetic energy, you need to use the equation 1/2 mv squared. So when you calculate the kinetic energy of the boy, you take half his mass times his velocity squared. 1/2 times 50, his mass, times 5 meters per second squared. The way that this works is the exact same way as your exponents and your values, as well as your variables, work in algebra class. So your 5 will be squared, your m, your meters will be squared, and your seconds will be squared. So you will take 50 times 5 squared, which is 50 times 25, because 5 squared is 25. And then you'll end up having a meters squared and a seconds squared. And you need to make sure that you preserve those things. You can see the answer. The baby's crying, so I got to run upstairs real quick. I'll be back in Kinetic and Potential Part 2.